All right, so here we are on number 3. Number 3. A lot of this is what we've been working with. Make sure you are really wrapping your head around what we're doing as far as understanding what these numbers mean. So usually we have to answer the following questions. How much money was in the savings to start? Well, to start means when the 0 time had passed. So at 0 time had passed, it's going to be right here, and this is going to be, I believe, 40. And what is the rate of change? Again, use a nice, pretty point. So I would use this point and this point right here. I know it's kind of hard to see, but those are the points we identified earlier. So this is 60, and it gives me 4. Okay, so from here, which was 0, 40 to 4, 60. So I went up 20. This is up 20 and over 4. So $20, so that's my savings in 4 weeks. So it's going to be $5 per week. Sketch a second line so if the amount of savings started at 60, but the amount deposited each week stayed the same. So that means I'm going to actually keep that same rate of change. I'm still going to go up 20 and over 4. So starting at 60, up 20 and over 4. 1, 2, 3, 4. Up 20 and over 1, 2, 3, 4. And then draw your line. What can you tell me about the 2 lines? So you tell me, what can you tell me about those 2 lines? Oops, that's not a very good line. There we go. If the cost of $25 to rent a car and it's 10 cents per kilometer to drive, create a graph and scenario. Hint, if you do not give the car off, drive the car off the lot, you still owe $25. So that would be $0.25. So go ahead and fill out the table, knowing that it's $25 or 10 cents per kilometer plus the 25. Pause me and try it. I will tell you that you have numbers through here and you get 30, I believe, down here for 50. So the rate of change in this is going to be the 10 cents per kilometer. So 10 cents. And it's going to be 10 cents per kilometer. What is the value? Or you could also say it is 1/10 if you want to put it that way. What's the value on the y-axis? That means when the value of x is 0, which happens to be right here. The value on the y-axis is going to be the 25. And then what does that represent? Well, look at what is my y value here. This is x and this is y. What's the y value? So make sure you put that here. This is going to be your y value, which is cost, and this is your x value, which is distance. And then go ahead and graph that. Now, the challenge here is that you actually have to graph 25 to 30 on your y-axis and 0 to 50 down here on the x-axis. I would probably go by 10, 20, 30, 40, 50 on the x. That gets me my 0 to 50. On the y-axis, I believe when I solve this out, I believe I end up with 26, 27, 28, and 29. So I need to go from 25 to 30. I'm going to go like this and cut my graph and say we're going to start here at 25. And at 10, I'm at 26. 20, I'm at 27. So 26, 27, 28, 29, 30. All the way to 50, I'm at 30. And draw a pretty line. Don't forget to fill in those extra pieces. I will be looking for those. Number 3A. What is the slope of this graph? Well, this graph I'm looking at is right here. So what kind of slope is that? And then interpret the rate of change. explain or state in words. And then how many books has this person read in 2 weeks and then 4 weeks, because this is the number of books. The next one, what is the slope of the graph? Well, again, the slope is going to be the rate of change. So from one to the next, one dot to the next. And I'd like to use pretty points. So there's a pretty point, there's a pretty point, there's a pretty point. I'm going up 1, 2, 3, over 1, 2. Going up 3, over 2. Interpret the slope as a rate of change. Well, it's the cost in per mile. So it's going to be the cost per mile. So in this case, it's going to be $1.5, $1.50 per mile. And if the distance is 0, that means the y-intercept. And the y-intercept is going to be 15, which means that's how much it costs if you go 0 miles. It costs 15 if you go 0 miles. All right, so now we're into the new stuff. Okay, so as we get into the new things, we're talking about intercepts. So x and y intercepts are where it crosses the x and y axes. So here's like the x-intercept is when y is 0, and the x-intercept is when, or excuse me, y-intercept is when x is 0, and x-intercept is when y is 0. So basically, if I were making a chart, it would look like this is my y-intercept, and this one would be my x-intercept. So some zero sum number, and then some number 0. So the x-intercept is where it crosses, crosses the x-axis. It's going to be some number 0. A y-intercept is where line crosses the y-axis, and it's going to be 0 some number. So for the next 2 problems, I want you to plug in a 0 and solve for x, plug in a 0 and solve for y. So basically making that chart. 0 for x, solve it, 0 for y. So 0 for x would make this a 0. If I solved it from there, I would end up saying 2y equals 6, so y is equal to 3. And then if I let this be your x, but then this is your 0, I'm going to say 3x is equal to 6. Divide by 3, because 2 times 0 is 0. That gives me x equals 2. So my ordered pairs are 0, 3, and 2, 0. On B, the same idea. Plug in a 0 for x. So if I plug in a 0 here, this makes it 4 times 0 is 0. So I get negative 2y equals 10. Divided by negative 2, y is equal to negative 5. So my little chart, I'm going to have 0, 5. And when I plug in, this is your x value now, and this is your 0. I'm going to say 4x is equal to 10 divided by 4. X is equal to, that'd be like 5 halves or 2.5. So 0 here, and it's going to be 2.5. And the last one. Try it on your own, please. Don't forget that negative. Watch those negatives. You need to have work, but I will tell you that it's going to be 5, and when I plug in a 0 here, kind of cover it up, gives me negative 3. So how do we find those intercepts? Okay, so how do we find them? Well, basically, plug in zeros and solve. So I'd like you to do just that for numbers 1, 2, and 3, please. They do fit on the graph. So if you get something that doesn't fit on the graph, then you know you're up to something wrong. Okay, you have to show your work, but I will tell you. So pause me and do your work. So this first one, I end up with 0, 2, and I end up with 5, 0. Plot those two dots, please. So 0 up 2 and 5, 0. 1, 2, 3, 4, 5, 0. And make a pretty line. Try the next two on your own, please. Concept 2. When I give you an equation, I want you to label the intercepts from a slope-intercept form type equation, or y equals mx plus b format-ish, or any kind of linear format. I want you to plug in a 0 for x and solve for y. So again, same thing. Oops. I'm going to say let y equals 0 equals 5 plus 10x. Take away 5 from both sides. Negative 5 is equal to 10x divided by divided by 10. So now I end up with negative 1/2 is equal to x. So when y was 0, x is negative 1/2. And then I'm going to plug in a 0 for x, and I'm going to say y is equal to 5 plus 10 times 0. Well, 10 times 0 is 0, so y equals 5. And then plot the dots. And then go ahead and try b on your own. You should end up with, excuse me. This one does go off the graph. I kind of told you a fib on that one. 0, 15, and 5, 0. So this one, it only goes to 10, 11, 12, 13, 14, 15. And then 4, 5. I make a pretty line. We're cruising right along. Here we go. X and y intercept, I'm giving you x-intercept of negative 5, y-intercept of 6. So really what this means, it's going to cross the x-axis at negative 5. So that means it's negative 5, 0, and this means it's 0, 6. So negative 5, 0, and 0, 6. Same thing over here. Go ahead and write your ordered pairs, and then plot your dots for me, please. Then we get into ticket sales. Well, ticket sales, this is where we actually use intercepts. When I have tickets sold to play, advance tickets are $4, and tickets bought at the door are $5. Total ticket sales are $400. I will tell you this is our format that we're going to use right here. It's going to be the value, in this case, it's going to be value of advanced plus, times number of advanced plus value of door times number at door equals my total amount. So now we need to put in values that we already are given. So what we're given up here is that advanced are $4. So that'll be the value of $4, advanced. So it's 4 times, I don't know how many of those, so A plus the value at the door is going to be $5 times number at the door, we're going to call that D for door, equals my total amount is 400. So now I have an equation, and now we can actually sketch a graph for the possible numbers of people attending. So again, I can plug in my A and D. If A is 0 and I solve for D, that would be 400 divided by 5, which is 80. And if I plug in a 0 for at the door, 0 at the door is 0 there. So 4A is equal to 400. So it'd be 100 of them in advanced. So now I can draw my cute little sketch, because that's the next thing it says, is sketch the line. So I know I've got advanced and I have at the door. I need to go to 100, I need to go to 80. I'm going to go in 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is going to be my 100. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go to 80, which is right here. 100 is right here, and I make a line that connects them. I can't go into the negative either way because I can't necessarily have negative tickets. Now, how many tickets were sold at the door? 50 were sold in advance. So if I want advance, that's right here. That's the number of them, and the value is 4. So I'm going to plug in 50 for A. So 4 times 50 plus 5D equals 400. This gives me 200. And then solve that out. So I end up with D is equal to, well, let's see, minus 400 would be 20. 20 divided by 5 is going to be 40. So that means at 50, 1, 2, 3, 4, 5, I should be at 40. 1, 2, 3, 4-ish. Go ahead and try the stacking one as well. I will tell you that I have 2 different kinds. So stacking crates, I have 2 different size crates. I've got 2-foot crates and I've got 1-foot crates. And I have a total of 8 feet. So again, I'm going to use this ABC format. I've got 2 items and a total. So 2 items and a total. My total is 8. So I'm going to say a value of 1. In this case, it's going to be the size of 1. Size of A times number of A plus size of B times number of B equals total. So as I write this, my size of 1, I'm going to say I'm going to call my 1-foot ones my A, and my 2-foot ones are going to be my B. So 1 times A plus 2 times B gives me my total 8. And I can sketch this. This is my A and this is my B. If I were to solve this equation, A and B, let x equals, or A equals 0. So if A is 0, 1 times 0 is 0, 2 times B equals 8, so B equals 4. If I plug in a 0 for B, I'm going to have 1A equals 8, so it's going to be 8. So 8, 1, 2, 5, 6, 7, 8, 0, and 0, 4. And there's my possibilities. So there's sketching my graph. Now it says you stack 3 of the 2-foot crates. So 2-foot crates, let's say I put it in right here for B. And if I were to say 1A plus 2 times 3 equals 8, that's 6. So take away 6 from both sides. And I end up with A is equal to 2. So that's going to be 3, 2. 1, 2, 3, up, 1, 2. And it should be on the line. I said that wrong, didn't I? 2 should be 1, 2, 3. Excuse me. There we go. 2 should give me 3. There we go. That's much better. At 2, I'm at 3. Yeah. Sorry about that. All right, next one. Concept 3, we're going to be writing, applying linear model and intercepts to repay your debt. So you borrowed this much money. That's your starting amount that you borrowed. Repay a debt at $150 per month. That's right here. And this is your debt, so it's negative because you're in debt. You borrowed it. T is time in months. Find the intercepts of the equation. So really I want to go like this, and I want to say that T and D. D is my y-intercept, or my output. If I plug in a 0 for T, that would be 150 times T, which is 0, which would give me negative 1800. In reverse, if I plug in a 0 for D equals 150 T minus 1800, at 1800, solve it, I get 1800 equals 150 T and divide by 150. So T ends up being 12. So 0 here gives me 12 months. Now explain the meaning of the answers that you found. Well, negative 1800 means that I had 1800 or $1,800 debt to start. And the 12-0 means can pay off to 0, owed, by 12 months, or in 12 months. Right, so now we're into writing equations. So we're going to write equations, and first thing I want you to do is I want you to graph each of these. Keep in mind that this is like 1.5, this is like 2.5, and this is going to be 3.5. That might make more sense to you, especially thinking about money. And then I want to write an equation of y equals mx plus b. Remember, this is when x is 0. So the b value is value of y when x equals 0. So for instance, right here, that's my y-intercept. And now I just need to find my slope. How much am I changing each time? Up and over, up and over. Finish that out on your own. And now you are to your exercise number 3, or your practice number 3. Again, don't forget this is distributive property. Combine like terms and then solve. Here you're just solving, line down the middle. Here's best guess to determine the slope. I will give you on number 1, here's here and here. Number 2 is here and here. Nice, pretty points. This is a vertical line, horizontal line. And this one, I'm going to say you go from here to here. So don't forget to do your right triangles on those, please. On this section, that's kind of opposite of what I really like. I like to do my rise first and then my run. So I like to go up or down and then across. So I would prefer to go from here to here. So basically, this dot is 1, 3, and this dot is 2, 3, 4. 4, or I should say 4 is right here. 4 and 9. So my rise and then my run. I went over 1, 2, 3. So that would be my horizontal change would be 3. My vertical change would be from 3 to 9, which is 6. My rise over run would be 6 over 3, which reduces to 2 over 1, or just 2. Now do the other 2 on your own. So again, try to go up and then over. Describe the procedure finding slope between any 2 points on a line. You can do that. And then on this one, please try it. It is this is U and then V, and then this is S and T. And that's it. Thank you so very much.